This video is on the stereochemistry of E2 reactions. The E2 reaction can undergo two forms of elimination. You can have Syn elimination, where your leaving group and the hydrogen are on the same face, seen here. Notice that the Newman projection is eclipsed for a Syn elimination to occur. Or you can have anti-elimination, where the hydrogen and the leaving group are anti to each other, as seen here. The anti-elimination is favored as it is lower energy. So whenever you have a choice of whether to do an anti-elimination or a Syn elimination, do the anti-elimination because it will be lower energy. You will only encounter Syn eliminations in situations where anti-elimination is just not possible. Now you practice. Show the Syn and anti-elimination products of these following reactions and state which one would be the major product. You may pause now. And here are the answers. Elimination on cyclohexanes occurs exclusively anti. This is referred to as trans-diaxial elimination. Little hint here, the hydrogen and the leaving group must be axial for this reaction to occur. For example, let's draw the lowest energy conformation of this molecule. Well, as the leaving group is equatorial, we cannot depict a reaction occurring. No reaction would occur with this molecule. However, if we ring flip it, and we now have the chloride axial, we notice that there is a hydrogen on the carbon next door that is also axial. This would be the hydrogen that is leaving, as it is anti. Therefore, the product that we form in this reaction is exclusively this one. Notice that we can't form the double bond in the other direction because there is no hydrogen present, axial, anti to the chloride. It is an isopropyl group instead. Now let's look at this structure here. We've changed the stereochemistry a little. If we draw the lowest energy chair conformation, we'll notice that this chloride is axial. However, it has two axial hydrogens that are anti to it. If we look at the products, we'll notice that the one with the more substituted double bond has a higher percent yield, i.e. there will be more of it. Why is that one favored? Well, that can be boiled down to the Zaitsev Rule, which is an empirical rule through experimentation. It states that major alkene is always the more substituted one, because the more substituted your alkene, the more stable it is. Now you try. What would be the major products of these two reactions? You may pause now. And here are the answers. However, there is one exception to the Zaitsev rule, and that is the Hoffman elimination. The Hoffman elimination occurs when there is a quaternary amine, where a tertiary amine group is the leaving group and can be eliminated. Due to its bulk, it actually follows the Hofmann rule, where you form the less substituted product. This makes sense if you draw a 3D model of the structure. A quaternary amine is always going to be sterically hindered, and therefore if a base needs to approach to remove a proton from an adjacent carbon, it's going to have to be on the less substituted position because that's probably the only hydrogen it can access. Anyway, so if you see a quaternary amine, assume that's probably going to be a Hoffman elimination, and hence it's going to follow the Hofmann rule. Here are two practice problems. You may pause now. And here are the answers. And finally, the big however. Whether the E2 reaction follows Zaitsev or Hofmann, if conjugation is possible, it will form a double bond that is conjugated.
So it does not matter where it's going to be forming, the more substituted, the less substituted. If there is conjugation, it will form that bond. Recall, what is conjugation? Conjugation is when you have two double bonds next to each other. So, for example, in this here, if we were to assume regular Zaitsev rules, we would expect to form this double bond right here. But instead, because we have conjugation with the aromatic ring, we will most certainly form this as our major product. Now you try with these two reactions. You may pause now. And here are the answers.